All right. Well, we've got some people coming into the room. So, and it is 12 o'clock. So I just want to welcome everybody to our September 2023 third Thursday. And thank you everyone for coming. I understand it's a busy time with harvest and the nice weather that we have outside here in the Okanagan today. Our presenter today is Dr. Sepideh Adabi, and she's going to be talking about sustainable cutworm management and some of the biological controls that we can use for managing cutworms. I'll just move to this one. So Dr. Adabi is a research scientist and faculty member at Kwantlen Polytechnic University, and an open learning faculty member at Thompson Rivers University. She currently serves as the president of the Professional Pest Management Association of BC, with a PhD and an MSc in entomology, along with a BSc in plant protection against pests and diseases. Her expertise lies in the development of environmentally sustainable microbial pesticides and integrated pest management. She also specializes in insect population dynamics, biological control, the development of insect frass in agriculture, and the intricate interactions among natural enemies, pests, pathogens, and their ecosystems. Through her research and teaching, she is actively contributing to sustainable pest management practices and the development of eco-friendly agricultural solutions. So welcome, and thank you for coming. I'll invite you to share your presentation.
Thank you so much, Kate, for the great introduction. Good afternoon, everyone, and thank you for joining. Let me share my presentation. I go for the first page. So today we're going to talk about the cutworm damage and the challenge of the managing cutworm in vineyards. We're going to talk about the available biocontrol tools, the mode of action of the biocontrol tools, when is the best time to apply the biocontrol tools in vineyards, and then I'm going to share the result of our trial, which are efficacy trial of our projects, and then share the result of applying the product which we applied in organic vineyard in Okanagan Valley against the cutworm, and then result of bud damage and cutworm monitoring, and using pheromone trap in vineyard, and talk about the next step. Let's get it started. Based on the information about the climbing cutworm obtained from Dr. Tom Lowry, AAFC Summerland, we know climbing cutworm are responsible for 98% of the bud damage in vineyards in Okanagan Valley. So the climbing cutworm, overwinter climbing cutworm, show up in early spring, and coincident with bud damage, they climb the vines and damage the. Actually, sorry, what happened? Okay. Sorry, now my computer. Okay, work. So the late instar larvae climb the vines and consuming the bud, considered with bud develop. So we took the photos when we monitoring the bud damage after midnight. You observe here the, okay. We observe the cutworm damaging the developing buds and develop shoots here. And look at this photo, cutworm damage leaf. This photo probably not cutworm damage, and this cutworm found from digging the soil, but probably not climbing cutworm. All the cutworm found in a vineyard are not responsible for bud damage. There are not all climbing cutworms, probably armyworm or some other species of the cutworm. So the cutworm in June pupate in soil, and from June to October, you might see, to September, you might see the moth, and the moth lay eggs in September, and newly hatched larvae show up in October or November and overwinter and complete the life cycle. So what's the impact of the cutworm in the managing of the cutworm? What's the challenge of the cutworm in vineyards? The economic threshold is typically 3%, but it varies from 0 to 15% due to the value of the wine grape. And there are only 3 available chemical insecticide registered in BC. One is Intrepid, the other one Pons and Alta. There are some concern using Intrepid and Pons because of the pest resistance. They are not selective for non-targets, and also adverse effect on environment and human health. And they allow just use on truck and soil. And the only option would be Altacor, but Altacor, the risk is in using Altacor increased when we use frequent Altacor. So pest resistance happen when we infrequent use Altacor. So pest research and pest replacement. There are some documents about some pest indicator like diamondback moths, like Spodoptera, which already resistant to Altacor. So about using pesticide, do you think how much the pesticide when you apply approach the target pest? A paper published in 1995 tell us only 0.1% of the pesticide applied approach the target pest, and more than 99.9% moving to environment, which is a significant number. So the only option, which is a sustainable option, could be microbial pesticide, which most of them are soil-dwelling microorganisms. They stay in soil and taking advantage of the environment and make their population, build up their population in environment and attacking other pests. So what are the microbial or options, or what are the biocontrol tools options? In our research, we used 3 entomopathogen or microbial insecticides. First, the fungal entomopathogen, we use Beauveria bassiana and Metarhizium. The nematodes, nematode entomopathogen, and the viruses, baculoviruses. Also, parasitic wasps like Trichogramma. Let's review the mode of action of each entomopathogen. First, Beauveria bassiana as a fungus. Beauveria bassiana spores must contact the, for example, cutworm skin or cuticle. The spores might germinate, penetrate the skin, produce spores and toxin. The toxin kill the larvae or larva, and the spores use the nutrient of the larva and then emerge from the cadaver and stay in environment and spread the spores and kill more cutworms. How about nematodes? Entomopathogenic nematodes. The entomopathogenic nematodes actively seek out the cutworms, find the cutworm, penetrate from a natural opening, and release symbiotic bacteria. Symbiotic bacteria kill the larvae, and the nematode use the nutrient and reproduce more generation, complete 1 to 3 generation, and then leave the cadaver and seek out more cutworms. Baculoviruses. Baculoviruses particle must be consumed by cutworms. In midgut of the cutworms, the baculovirus particles stick to a membrane wall of the midgut and multiply and kill the cutworms. Parasitic wasp. Parasitic wasp, Trichogramma. We will use the Trichogramma. Trichogramma adult find cutworm eggs. The cutworm, Trichogramma lay eggs in cutworm eggs, and then Trichogramma larvae complete its life cycle inside of the cutworm eggs and eventually emerge. There are some natural enemies which are not commercial. For example, we find this cutworm over our monitoring in Okanagan vineyard. You can see here a cutworm with a group of parasitic wasp larvae ready for become pupa. So they become pupa, they produce cocoon, and now you can see the dead larva here. The pupae become dark, and eventually this parasitic wasp emerge, and we send for ID, and the name is Euplectus. There are only 8 species of Euplectus ID'd in North America. So some of the cutworm controlled naturally by natural enemies. So we know the available biocontrols. So, but when is the best time to use this biocontrol? Because the critical time is about the using the biocontrol is the timing. When is the goal time to use the biocontrol? So let's review again the life cycle of the cutworm. You know, the cutworm show up in early spring, damage in early mid-spring, and lay eggs in September, October, and over winter. So the cutworm must be controlled in the most susceptible stages. So the most susceptible stages is in spring and fall. But temperature might be cool at this time. So we have to find the biocontrol tools which are adapted to cool temperature. What's the temperature at spring and fall in Okanagan? So in March, maximum temperature would be around 15 degrees, and in May, the mean temperature come to 15 degrees, and in September, the mean temperature 15 degrees, and in October, the maximum temperature comes as 15 degrees. So we picked 15 degrees as our standard temperature to test our product, and 15 degrees as the lowest temperature which our product can be function. So we picked 3 objectives. If the product can be effective against cutworm, can kill cutworms. If they are effective, can kill the cutworm at low temperature like 15 degrees, because you know the most of the microorganisms are effective at 25 degrees optimal temperature. So if they are effective, we can combine them to reduce the dose of the product and reduce the cost. So in that case, we start our trial. We picked 2 species of the climbing cutworms. Noctual commies, we picked noctual commies as invasive and aggressive cutworm, and Abagrotis orbis as the most abundant cutworm. 84% of the damage of 98% of the climbing cutworm, 98% of the climbing cutworm bud damage is from Abagrotis species. So in for our trial, we used 8 Beauveria bassiana isolate. 2 isolated from Okanagan from Dr. Tom Lurie, and 4 coastal isolate from our lab, and 1 tropical isolate, and 1 botanic garden commercial isolate. So we subcultured the isolate on PDA, and we made the suspension. We use broccoli leaf disc. We grow the broccoli in our facilities, and disinfected broccoli leaf disc immersed in the fungal suspension and left for half an hour to be dry out, because our trial was kind of residual test, and 1 leaf disc transferred to each cup plus 1 larva. They sealed and left at different temperature to assess every day for their mortality and sporulation. So let's see the result. This graph showed the mortality percentage of the second instar of noctual commies at 15 degrees, 20 and 25 degrees Celsius. At 15 degrees Celsius, the coastal isolate 2052 and 190 was responsible for 50% of the cutworm mortality. And at 20 degrees, also 373 and botanic garden was responsible isolate. 2 weeks later, at 15 degrees Celsius, 190 was responsible for 85% of cutworm mortality, compared with botanic garden, which was only 50% of the cutworm mortality. This graph, this slide shows the same data, but for Abagrotis. At 15 degrees Celsius, look at the data. For example, 190 works similar as botanic garden, and 2 weeks after exposure at 15 degrees Celsius, almost all the isolates caused 90 to 100% of the larval mortality. So for further trial, we picked 1 Okanagan isolate and 1 coastal isolate to continue our trial. So here I like to share with you the efficacy of this isolate for other pests, which is a cabbage looper, which published in Pest Management research report. Here you can see cabbage looper larva and sporulated larva. The graph show the mortality of third instar of the cabbage looper via direct contact and residual contact toxicity. The botanic guard presented with the green line. Look at the green line here and our isolate here. And this slide present isolate against diamondback moth, Plutella, which is resistant to almost every single chemical pesticide. Look at the data, almost same trend. This slide shows the cocoon or pupa of diamondback moth, which received the fungal suspension in its larval stage, but sporulated in pupa stage. Interesting. So this slide shows lethal time values for isolate, or the time of the Beauveria bassiana isolate need to kill the cutworm or the pest. For example, for Noctacomis in 15 degree, look at the data for each 22 for Orbis. In 5 days, could kill 50% of the population. The same trend for Abagritis orbis. At 20 degree, it followed the same trend. At 5 degree or even less than 5 degree, could kill the 50% of the population. And for 373, you need a little bit more time, around 7 days. And here, look at the data, almost same trend. And this graph showed the little time need to kill 50% of population and 90% of population. The purple bar showed the time need to kill population of the by botanic guard. You can observe all the R isolate, except the green one, which is not very desired isolate, are less than purple bar, which present the botanic guard. Shorter bar indicate higher toxicity, quicker kill the larvae. So same trend for diamondback moth. Could kill all the isolate could kill the diamondback moth in 2 to 3 days. Look at here. So we continue the trial with nematode. 3 species of nematode, Carbocapsid, Feltii, and Bacteriophora. And we applied the nematode. We used commercial nematode species, and we prepared the suspension. We applied in soil and one larva, one leaf this in soil, and monitor the larval mortality every day and look at the results. This test conducted on Abagritis orbis and Noctacomis at 15 degrees Celsius, at 20 degrees Celsius, and second instar of larvae and fourth instar of the larvae. We learned Carbocapsid and Feltii was responsible to mortality of the larvae compared with bacteriophore. So we picked Carpocapsae and Feltii to continue our trial. But which rate of Carpocapsae and Feltii? We picked 3 rate of Carpocapsae and Feltii. The middle rate is the rate of the recommended by a company, and we use low rate and high rate. Actually, the high rate is recommended by company also. We compared which rate is the best, and we learned between Feltii and Carpocapsae, because we could just pick one species. We learned for commies, Feltii work better than Carpocapsae, but for Orbis, both work well. So, and in this case, we picked Feltii and 2 rates. So the next step of our trial, we used a combination of the trial. In this trial, we used Beauveria bassiana 373, 252, and Botanic Art as commercial Beauveria bassiana, and 2 rate of nematode, which was the Feltii. And in the next step of the combination, we used just 1 rate of the Feltii. We looked for which one is the best, which we just picked 1 rate of the Feltii, and we reduced the concentration of the Beauveria and continued the rate. But the first combination trial, we applied Beauveria and nematode at the same time. But in the second one, first we applied Beauveria, and a week later we applied nematodes. Look at the data. This data is for Orbis. 4 days post-exposure at 15 degrees Celsius and 20 degrees Celsius. The purple color show additive interaction, and the red show synergistic interaction. You observe additive and synergistic interaction. For Noctua comets, 1 week post-exposure for 15 degree and 2 weeks exposure for 15 degrees Celsius, and at 20 degrees Celsius, 1 week post-exposure. Because Noctua comets is harder to be killed compared with Orbis. So, almost same train. So, I can say combination of isolate plus lower concentration of Feltii resulted to synergistic effect. So we picked lower concentration of the Feltii to continue interval combination trial. In interval combination trial, which we applied nematode a week later than Beauveria bassiana, we observe additive and synergistic effect again. And for Noctua comets, same trend. So we test this combination trial with same procedure in pot using the plant dandelion as a preferred host plant of the Noctua comets, and we learned the combination of isolate plus Feltii resulted synergistic effect, but when nematode applied a week later than Beauveria bassiana at 15 degrees Celsius. So After this trial belonged to a project run from 2019 to 18 to 2021. But from here, it's a 3-year project started 2022 and continued to 2025. We used baculoviruses and 2 commercial entomopathogens, Beauveria bassiana and Metarhizium, but not for cutworm and wine grape, for spider mites and whitefly. So the product provided by Entomopathogenic Canada, our industry partners, and we continue the same procedure. And I'm gonna show the results, and we used the most aggressive pest, which was Noctiocomys. Look at the data. Bassider presented with blue line. The Bassider. Oh, Bassider was Beauveria bassiana. Beauveria bassiana, a strain of presented by Entomopathogenic Canada. Bassider was responsible for highest mortality compared with Botanigard, which is commercial Beauveria bassiana. And Exilon, Lupex, and Spodovir, baculoviruses, but for other pests, for example, Lupex for cabbage looper and Spodovir for Spodoptera. Baculoviruses are very high host selective, and we didn't expect they work, but just we want to try. And here are the data for trying at 20 degrees Celsius. Bassider show promise. And later we test Bassider, also Nomoprotect, which is a Metarhizium, and on force instar of Comys. Compare with our isolate 190, 252, 372, and 373. But Bassider used one, and Bassider and Nomoprotect used 1/4 of the concentration was 1/4 of our product. And I believe it's still promising. And it could be registered for cutworm control in vineyard. So we decided to apply this product in vineyard in Okanagan Valley. But in spring, we have to know when is the best time. We run a monitoring, bud damage monitoring and cutworm monitoring, and our partners, our team member monitored whole vineyard in early spring, and we found larvae. Here is a wireworm, cutworm in different species, different size. Look at the cutworms, but may not all responsible for bud damage, may not all are climbing cutworms. Where we found the cutworm, we marked with flag. Here is the early bud damage for cutworms, for example, here, cutworms here. Different type of cutworms, different color. So based on the data we collected, we marked the hotspots, and we designed the trial, and we sprayed Bassider in 3 rates, plus 1 untreated treatment and 1 positive control. We use Entras as positive control. And we had 8 plots per treatment. And we had 1 initial assessment, but damage assessment. And we had 4 times application of Bassider and with 3 or 4 interval days. And before each application, we had assessment, and we marked the bud damage with a permanent marker before application with different symbol to avoid recounting the bud damage every time. And to ensure the bud damage caused by cutworm, we run 2 night check and check the vineyard after midnight and took this photos. And look at the data we collected. First application, second, third, and fourth application. Here are the data from net bud damage. 5 days after the first application, still we can see the damage. But 8 days after the first application, which is 3 days after the second application, we can see the reduced damage in Bassider high rate and Entras. And we can follow the same trend until 27 days after the first application, which we follow 2-3 weeks assessed after the last application. We use climate control units provided by Farmer High, and the climate units set up in one of the blocks close to our trial, and the sensor could be set up in soil. It shows us the fluctuation of the temperature, humidity, pressure, soil moisture, and soil temperature, and can help us decide when is the best time to apply our production, and also can help the grower to make decision for their water application or other application. So we had another application in fall, but for fall we have to know, okay, when is the best time to apply, when the larvae are available, or for the Trichogramma, when the eggs are available. So for address this, we applied the pheromone traps. And the pheromone traps help us to know when is the peak of the flying of the moth. So we used 5 different lures, abacrotis lures, custom made by our partner, industry partner under Canada. And we purchased 4 other lures, alfalfa lures, bit armivore lures, nocturnal lures, and plant extra. The plant extra lures just attract bees. So after a week, we remove the plant extract lures, and the 25 traps, which when we remove plant extract, remain 20 traps set up over the vineyards. And every week we collected the moth and labels and I did look at the result from June 16 until yesterday. We can see the dominant species is Abacrotis radii, and Noctua camis just started yesterday to fly. And based off this graph, we can decide when is the best time to apply our product this fall, and we will assess our result next spring, which next spring we will apply another bachelor trial plus other product trial. So the next step for fall application would be, we'll definitely apply bachelor. One of our Beauveria bassiana, which is 373, we already mass produced and is ready for application. We're gonna purchase feltii, combination of feltii and our isolate, and one of the treatment would be untreated. Also, we need to apply Trichogramma species, but which species is appropriate for applying against cutworm, because cutworm lay eggs around close to ground, and we have to know which species are effective and search close to the ground. So in that case, we run searching behavior trial of the 4 different species of the Trichogramma, and next year fall we're going to apply Trichogramma as another treatment of our trial. Take home message. So native Beauveria bassiana isolate, including coastal isolate 252 and 190, and a Canadian isolate 372 and 373, show promise and can control climbing cutworms at lower temperature, and they can be option to be registered in Canada as new bioinsecticide. Bachelor show potential for controlling climbing cutworm, but need further trials to optimize its effectiveness. Entomopathogenic show promise in controlling cutworm, seems to be more effective at higher temperature, but further testing is necessary to determine its full effectiveness. The further testing is already running in our lab. And entomopathogen nematodes have proven effective in controlling cutworm even in low temperature, and interval combination of Beauveria bassiana isolate and nematode showed synergistic or additive interaction, which reduce the dose required for both product and show a viable alternative method for managing cutworm in IPM programs. So I would like to appreciate everyone and all organization to support us to conducting this project. And thank you so much for attention. And if you have any question, I would be happy to take your question. Thank you so much. I can stop sharing, or I can keep my slide to show if you have.
Hi, Sepideh. We do have a question from Hans Buchler. How long would residual toxicity of the bassiana be active under field conditions? And how would temperature and related humidity impact effectiveness?
Okay, yes, definitely. Definitely the humidity is important and temperature is important for Beauveria bassiana, and it's critical factors. But I have info. One of the reason actually the bachelor, the low or mid rate of the bachelor didn't show actually significant difference with untreated. I believe was the humidity. The humidity was very low in summer. It was, for example, around 50 to 40%, which is very low in a spring, sorry, which is really low humidity. So we need higher humidity for Beauveria bassiana to be effective. So, or we have to increase the rate. For example, I can show the. Let me to slides from would be definitely easier to not goes that way. Wait. Okay, I cannot exit from the okay, it doesn't work my computer. Okay, work. So let me share it here again. So here, for example, there is no significant difference between untreated and the yellow, which is low bacillus rate or the mid rate. So we think because of the low humidity. The temperature 15 degree work, 20 degree work, 20 degree definitely work very well, but 15 degree would be a slower, but I can say a 1.5 time we need. For example, if 20 degree work in a week, for 15 degree, you need 10 days, for example, or 12 days, for example. But humidity is a matter in spring in Okanagan Valley. But year different.
Perfect, thank you. We also have a question from Lindsay Hainstock. Do you see the work leading to a model that can be used with weather data for control decisions?
Definitely. Yeah, definitely. We're gonna use this data. We have some plan, and we're gonna use this data for degree day data for could be for disease, for we're gonna use for cutworm, for example, life cycle, and could be for wine grape, and could be for disease as well.
Perfect. Okay, and we have one from Mehdi Sharifi. Does the presence of ground vegetation cover crop impact cutworm populations? And if so, are there specific plant species that may promote the proliferation of cutworms? For instance, can cutworms utilize root crops such as radish and turnip as a food source, leading to an increase in their numbers?
Actually, I'm not sure about which type of cover plant are available in vineyards, but we had a test on shepherd's pears and dandelion, and on noctocomies, and we learned noctocomies prefer dandelion and doesn't like at all shepherd's pears. And we learned shepherd's pears might be a good option to control noctocomies, but might pursue noctocomies to damage wine grapes. Or dandelion might keep noctocomies.
Some integrated pest management options there. So from Lisa Wamble, what would be the chance that registrants of Bassador and Botanic Art would want to put the money into a potential label expansion for targeting cutworms in Canadian vineyards? Even if there's supporting data from BC, we're such a small market and current Canadian labels only have greenhouse use.
But Botanic Art is not under control, but Bassador is under McCanada. Under McCanada is our partner, and one of the objective of this research and this project is registration of the ambassador in Canada, and we're running this trial for registration. If our trial results succeed, and we can register soon ambassador to control cutworm in vineyard, especially for climbing cutworm in vineyard soon. We're running this fall application, and next spring another application, and if we meet the result, they're gonna register soon and would be available soon.
Hans had a comment that shepherd's purse is effective on abagrotis.
Oh, abortus.
Yeah.
Might be abortus, might a mistake, might be, I'm not sure. I remember we ran a trial on about might be abortus noctilucmis. We test one of the species, might be abortus.
Perfect. Any other questions at all from our group here? What I'd like to do is this will be available on our BC Wine Grape Council website on the video link. So I'll be sending that out to everybody probably tomorrow. And if perhaps you had some questions for Sepideh, if we could share your email address, is that okay?
Yeah, definitely. My email address is on the last page here.
Perfect. So I'll share that out in our follow-up email that goes out. And Lisa says that she'll mention the Bassador as a potential solution for cutworms at the next minor use meeting. And so I guess also if there were people who are interested in being involved in some of the ongoing research, then you'd be open to talking with them about that, right?
Yeah, definitely. Yeah.
Yeah.
We welcome everyone who wants to collaborate in this research or upcoming research, or
Perfect.
any growers, any vineyards wants to be involved. Welcome to involve.
Okay, wonderful. And I'll mention that in our follow-up email as well. Our next third Thursday meeting is in October on the 19th. We're just working to finalize our presenter, but we'll be sending out some more information on that shortly as soon as we get that locked in for the remainder of the year. So thank you so much for coming, Sepideh, and thank you for speaking with us today. And thanks to everybody who's on the line. I hope you enjoy the rest of your afternoon.
Thank you so much for having me, and thank you so much, everyone, for your attention. Thank you.
Perfect.
Thank you.
Thanks.
Thank you.